Hello all, my name is David Ruck. I'm at the University of Maryland, Baltimore, here in Baltimore, Maryland, and this is Cytometry in R. So today we're doing one of the pre-course walkthroughs, basically looking at how to use version control software with Git. This is take 2 for today. The very first time I did it, I got 8 minutes in, and the slides did not change over, so we were having some technical issues. So this is my reattempt at that, and hopefully the slides will progress. So let's see. Double click. All right, I saw this slide change on the YouTube view, so I think we should be ready to go. So, the background as far as where you should be at this point of watching the video, you have gone through a couple of the pre-course tutorials, namely you have set up your own GitHub account, and you have also went ahead and installed the software that you need for the course on your own computer. Then we also had the Positron walkthrough tutorial where you basically saw some of the overview of the Positron IDE that we'll be using throughout this course. Now, when you're working with code, it is very important that you stay organized. Ideally, everything that you'll need for the code to run successfully should be kept within the project folder that you're working with. That enables you, if you're working with a collaborator, to just be able to copy the folder over to them, and then with minor fuss, be able to get the code running for them as well. Similarly, if you're moving between multiple computers, being able to go back and forth between computers readily would be very useful. Also, the advantage of if you're doing a version control software is if you have a code that's working yesterday and then you're making additional changes to it today, and all of a sudden it breaks, meaning your expected output no longer is being seen, having a history of the changes that you made between your current edits today and what you had that was successfully working yesterday will be immensely helpful when you're trying to troubleshoot exactly where your code has gone wrong. So especially in context of beginners, one of the things we often encounter will be we have misspelled a function name or misplaced a comma somewhere by accident from our keyboards. So having a software that's able to keep track of these things is very useful as you get started off. So for this reason, we'll be using the version control software Git. It is widely used by software developers and bioinformaticians worldwide, and it's a very useful tool once you know how to use it within your coding toolbox, which is why we'll be using it throughout the course and why I think it's important to start emphasizing how to use it at the very beginning of the Cytometry in R course. So, when we're getting started is, unlike one of the previous tutorials where we started off with a GitHub repository that we then brought to our local computer, in this walkthrough, we'll be doing the reverse. Basically, we'll be creating a new repository locally, we'll do some edits and creation of additional files present within our local environment, and then we're going to attempt to move this project folder to GitHub remotely so that we can then have access to it later on. So if you're opening Positron for the very first time, you'll see a view that looks something like this. What I'll ask you to do is navigate up next to your interpreter where you're able to select which language you're using. Select this little folder icon, and then you'll see the two options, both the new folder from Git option that you have used previously, as well as the one that we'll be using today, which is selecting the new folder from template option. And when we select this option, what we end up seeing is a couple templates that we can then be able to use. So Positron, unlike RStudio, is multilingual from the default. So you're able to do Python projects as well within it, but since this is a Cytometry in R course, we'll be using the R project template for our subsequent steps. So once we have selected this, we need to actually come up with a name for our project folder. Now, the most important thing I want to emphasize at this stage of the course is you should try as much as possible to use characters, i.e. letters, numbers, underscores, hyphens, within a name of a folder. All of these special characters, for example, @signs, $signs, hashtags, all these other ampersands, all of these different things mean special things to a computer. So if you're including those within a file path, you can oftentimes be misinterpreted as actual command. And that will cause your code to break. So as much as possible, when you're naming a project folder, name it something that doesn't include any of these special characters. Additionally, we need to decide where we want to store our R project folders because we'll be making a few of these throughout the course. So what I normally do in my daily practice is I keep all my R projects within my documents folder on my various computers. So this enables me to be able to find them readily and only have to change a few minor things when I'm using different computers at that stage. However, I have friends who will make a R project folder on their desktop and then keep all their R projects within that desktop folder. It really is up to you. The main thing I want to emphasize is the importance of keeping your particular sets of code always on a local computer. You don't want to save a project folder on OneDrive, Dropbox, or something else that's remote. The reason for this is the way those remote options in the cloud work is they're always trying to sync your local version with the remote, and oftentimes that can result in you being denied permission to edit code that's existing in the remote location. So at that point, you'll run into quirky kind of bugs that you can't really readily explain, which is all entirely based on your project folder is in a remote location on the cloud with permissions being restricted. So as much as possible, create all your project folders on your local computer where you actually have control of what's going on. And then the very last thing you should do on this screen is select that Initialize Git repository option. This will initiate the version control for this particular project folder, and everything will start at least being somewhat tracked from the very get-go. If you forget to click on this, you can still initialize this later, but let's go ahead and initialize it now. And then on the next setup screen, it just wants to confirm what version of R do you want to use for this particular project folder, as well as gives you the option of setting up a reproducible environment. This is a little bit more advanced. We will revisit this topic later on in the course, so for the time being, please just leave that one unchecked. And if all goes well, you'll have this little pop-up that says a new folder has been created, and do you want to open it within the new window or in the current window? So what I'll go ahead and do for this one, since I didn't have anything important open in Positron before this, is I'm just going to go ahead and select the current window option. So from the get-go, what I oftentimes will try to do is I want to keep things a little bit organized. So if I'm taking screenshots to document what I'm doing throughout the process, I want to keep those within their own specific subfolder. If I have data, I want to keep that within its own little data folder. So within Positron, if you navigate to the upper left on the primary sidebar, you'll see this little folder option, which will allow you to create folders. So right off from the bat, any project I'm making, I'll just make a little data folder as well as a little images folder, just so I can keep things a little bit organized. Additionally, we need to create a couple new files which we'll be working with. So the main types of files that we work with in the Cytometry in R course are going to be .r files and Corel Markdown files, which are the .qmd files. So .r files can only contain code as well as any comments behind a hashtag. These are often self-contained bits of code that you're not going to be actively editing and that you don't actually have to do extensive documentation on. So these are kind of things that you'll have run in the background to do a particular task. On the other hand, if you're actively editing the code and trying to see if stuff is working, or as well as being able to document what you're doing so that you're able to figure out how to change things in the future, what you want to be working in is what we call a Corel Markdown file, or .qmd. These are made up of have three main types of elements to them. There's a YAML header, which we'll go into in a little bit, as well as line sections that are just text, as well as sections that include code chunks where you can write actual code that will get run and executed on your computer. So we'll go into these in a little bit. Now, the way you go about creating new files in Positron is right next to that project option up here on the upper left side. There's a little one that gives you the option of creating a new file. Now, if you click this, it'll give you a little section where you can actually go in and name it. If you're trying to specify what kind of file this is, you're just really adding either .r or .qmd to the very end of whatever file name you're giving, just remembering to keep the file name without any special characters. So, when we're talking about QMD files, this is the one we're going to start off. I went ahead for my test example for this particular walkthrough just to call it example.qmd. And what you'll end up doing is at the very start of every Corel Markdown file, there's a little YAML header section. So YAML is a special type of language, but basically what this is doing is it allows you to fill in some metadata that can then get processed into different types of files. So if you're looking at it in the context of this very brand new blank example.qmd file that we have just created, if you're going to create a YAML header, what you need to do is basically come back in and add a little bit of we'll show you basically what you'll need to command. I don't want to have to fully write that out. Additionally, you can have sections that are text. So this is the example of the YAML. There's the 3 hyphens in a row, title colon, and then you can name the actual file itself. You can specify the format that you want to use. So within Corel documents, you can render them as websites, as PDF files, as Reveal.js slides, as well as Word documents. So this is the section where you can swap back and forth and be able to change what kind of outputs you're seeing on the actual document itself. Now, if you have not specified that a particular section is a code block, everything else within the document that's not the YAML header is assumed to just be text. So this can be used for documenting what you're doing, to give a little bit of background, other things of that sort. So what we end up seeing is if we want to actually run code, what we need to do is create a code chunk. And within a code chunk, we have options as far as do we want it to be run, as well as anything that's present is the code that's being executed in sequence. So to create a brand new code block, what you do is up here on the upper right side of the editor, which is this portion here, you'll see the option to insert a code block. Now, if you select this, you'll see it ask you basically what kind of language you want to use for this code block. And since this is a cytometry in R, we'll be using R for our little code block section. So as you may notice, if you come in here and scroll, you see this little code block when it's being inserted. It's basically 3 little tick marks, curly brackets, and then an R present. And then at the very end of the coding section, it's those 3 little tick marks again present on the row. So if you want to not have to go to the steps of adding in a code block by clicking on a location, coming back up here, inserting a code block, and selecting .r, you can also just type this out as you go. Just be very careful to make sure you have 3 tick marks on each side, or else the actual file itself is going to get confused, and you'll have splices as far as one code block running into the other, including text. So those are the things to keep an eye on when creating it by hand. So, for example, we are putting in a couple functions. There are general kind of functions we'll use for the beginning of the course. So basically, the little print function, and a function is designated by the presence of these little parentheses. It's placed within the code block within the beginning and the end of the code block, and then you have the options to be able to run the code. So you can see there's an option that says run cell, which will basically execute the command, basically sending that line of code to your console window, which is located down here, and then displaying any outputs that you get back from that code line. So if we do just that, we can see in a second what it'll look like. And hitting the little run cell option, you'll get print hello, and then you'll see the return output that we get back from the console is hello in this case. The other way of doing the same thing is if you click here, and then depending on if you are on Mac or Windows, holding down Control or Command, and then Enter, will just run whatever individual line of code your cursor is currently clicked on. And then that way you should be able to see what you're working with at that stage. So these are the 2 ways to run code. Generally, I'll do the run cell option if I have like a lot of different lines of code and I don't want to have to run everything all at once. On the flip side, what you can also do is if you have multiple code blocks in a row, you can do this run above option, which is just run all the code blocks that exist before it. So that way, if you have a script and it's established, you can just run the very last code block and get all the outputs that you need while you go on a coffee run. All right. And this was basically showing you the get a working directory file path option just to see where in the computer you're currently at. You can see when I run this function here, basically it shows us that we're in my documents folder within my Git practice project folder, which you can also see is up here and listed. All right. Now that we have introduced the 3 basic elements of a Cortal Markdown file, we'll be talking more about this later in the next pre-course walkthrough. Let's go ahead and start working on some of those basic elements of the local version control. So as you notice, as I started actually changing this file and adding little bits and pieces, there's always this little red circle that pops up. This is basically denoting that you have not saved any changes to this file. So if your computer crashed right now, those changes would not be actually saved. So if you hit the little save icon, this will now vanish, and then you'll actually get to a screen that looks something like this, where it's no longer present, but it's still showing up as green. Now, if you actually have Git set up for version control, which is what we did when we selected that first option, if you go over to your action bar and come down to here to this little fork option, you'll see this is the source control tab. As we start editing in the actual files, if we have not done any other steps in the version control process, you'll see all 3 of the files that are present within our project folder are showing up in green, and they all show up with the U attached next to them. So the U stands for basically it's been untracked or uncommitted at that point. So it's a file that has made its appearance within the actual project itself, but we have not yet told version control, hey, this is an important file, we want to monitor it over time. So this is what we'll be following and keeping an eye on throughout the rest of this walkthrough. So if we look at our little source tab, and it will open up here within our primary sidebar, we'll see at this point we have everything being untracked, but there's like little positive signs next to each file. If we decided, okay, this file is important to us, we want to actually have version control software Git track it for us over time, what we do is select this little plus icon to be able to add it, which will basically be called staging it, which basically means it's now, the software is now aware of it. It'll keep track of changes that are occurring to this particular file. So let's go ahead and do so for the example.qmd file, and at which point you'll see it appears in a new location, basically the stage location, the stage changes location. So this denotes files that are being tracked that we have an intention of being recorded as a next save state, i.e. basically if you're like thinking in the context of like a video game, the next waypoint where if worst case scenario you can fall back to in the future. At this point, what you need to do in the normal workflow process is you create a new file, you stage it. The very next step within the version control workflow is you need to commit it. So basically the commit is a save state or a waypoint. So once you have the files to a certain point where you're happy with where they are currently, you write a little commit message and then press commit. So in this case, we can do it by two different ways. The first way is via the graphical interface. So you can see we have our file stage. We can now write a comment, just basically describing what we have done, and then we can hit that commit option. If we do so, what we'll have to have pop up, especially if this is your first time using Positron, is it doesn't actually know who you are in terms of authorization to use Git. So it will ask you to provide some inputs as far as who you are and what your email address is. This will be used by GitHub as far as like crediting the correct author for each of the changes that are happening within the version control. So if you look at the output tab at the bottom of the screen, when you select that option to say show output, it'll give you the suggested lines of code that it wants you to run within the terminal. Now the terminal is that little tab next to your console window down at the very primary bottom portion of your screen. So this one, what you'll need to do is basically copy this section over, and then you just need to modify in your actual name and your actual email address. Now, if you're on Windows, you may need to hold down Control Shift and V when you're actually pasting to a terminal. It'll depend on your settings on your computer, so please double check the documentation we have on the website. It's a little bit better at explanation than me narrating it at this point. So what we're going to do, here's the documentation just in case in point. So coming back down here to the terminal, which is next to our little console tab, you'll see our particular computers there. And then this is the section that will be Control V or Control Shift V in to basically paste in the command that we grabbed from that previous screen. And then using your arrow keys on your keyboard, you'll go back a few bits until you're inside the parentheses. And then inside the parentheses is where you'll actually put in your email address. And ideally, use the email address that you use for your GitHub account. Once you're happy and you have edited in the email address, you'll then hit enter, at which point this will then be archived and you'll have updated the Git preferences as far as what your actual user email is. At that point, you'll go back and basically control and copy in the command that you'll need to do for providing your username. Oftentimes, I'm doing this as my actual full name, not so much the GitHub account username, so I'd use David Rock in my particular example. And once this is done, same thing, control and enter to basically go ahead and send that information to Git, which then it has both your name and your email address so that the commits are being properly authored as you go. So with these formalities of setup process now completed, you can now proceed to actually go ahead and proceed with your actual commit. So once you hit commit, basically that initial commit, the waypoint now becomes available down here under the graph portion of the primary sidebar. And if you hover just over this, you'll start seeing actually some of the commit details. Also, if you click on it, you'll actually see the changes that have occurred within the version control software since you have last done it. So in this case, we have not yet created example.qmd file before we started. So you'll see all the changes, basically everything we have done so far to that file is appearing on the right side of the version control screen, all of it being tracked in green, basically meaning all this is new material that has been added since we last tracked the file. All right, so now that we have done an initial change, let's go ahead and change the file a little bit more just so we can like kind of mimic what we'd be doing throughout the rest of the process if we were doing some editing. So let's go ahead and create a couple extra lines and go ahead and hit save. And at this point, unlike a previous one where we had an untracked file, because we now have example.qmd being monitored by version control, what we can see is instead of untracked, these changes have been recorded as being modified. Basically, meaning there's additional changes that have happened to your file since that last safe point, the waypoint, basically the last commit. So similar to what we had for that previous process, we can then repeat, stage this particular change, commit it as a new commit, as we go throughout the day. Basically, what I'll oftentimes do is I want to keep this as much as possible. Minor changes I don't go ahead and commit, but when I have enough significant work that would hurt if I lost the file, that's when I'll do an additional commit. So in this case, we're adding a few additional changes. And like I said, if you click on Source tab and then you click on a particular file, you'll see this example.qmd, basically the same name of your actual file, but then it'll show you working tree. This is basically the version control tracking file. Don't try to edit this form properly. You'd be editing over here. But then you can kind of see there's like little green highlightings for particular sections of text where you have changed the values. So for larger documents, oftentimes you'll be able to have the scroll bar and you'll be able to scroll down further and further until you see what you're actually interested in at that stage. Now, the very first process we just saw was making changes via the actual user interface within the action bar. So there's also the option of being able to make these same commit steps via the terminal, which we use to provide our email address. I covered this point a little bit earlier. Basically, is how often you should commit versus how often you should hit save. Basically, I commit every significant amount of effort where I want to at least document and be able to roll back to should the worst happen. All right, so if we want to go about doing the same process for these new changes we have just done, as we can see, the modified file is being displayed here. The step that equivalent of adding that particular file from this click option would be if you went down to your terminal and did the command git add and then the name of the particular file that you're doing. So basically, this is literally the same process as if you had clicked this little add option. And then, as you'll see, once you have run that command, you then have the example.qmd file now being visible on the stage changes location. So as you proceed with the next step, within the workflow we saw previously, we need to write a commit message. So if you're writing a commit message, what we're doing is basically using this particular command, git commit space hyphen M standing for message, and then within quotation marks, replacing what we want to actually provide as our actual commit message. So in practice, this is kind of like what we'll enter in on the terminal if you're trying to do it via this route. And once this is done, you'll see that new commit message has now appeared, and it has appeared under our graph in the primary left sidebar, being one commit above. And then if we clicked on that, we can see the actual changes as far as what's happened. So at this point, all this tracking of version control has been happening within our local environment, which is quite useful as far as being able to see the changes. So if something did happen, we can quickly open up our version control, see the two screens, kind of be able to pinpoint where has something gone wrong and be able to address it in turn. But the real advantage of local version control is that you don't have to deal with those multiple versions of the same file that all are different, slightly different from each other. If you have a GitHub account set up, basically all these little changes you can do, you can push these commits to your remote repository, meaning your GitHub account. And then if you are working on a different computer, just pull those freshly updated changes from your GitHub account to that computer. And then that way you're just working on the same file that's being kept remotely and doing edits as you go instead of having multiple different versions that are all slightly different from each other. So the previous pre-course walkthrough was covering bringing in a repository from GitHub. This one, we're starting locally and we're sending it to GitHub. Now, so far, 2 weeks into the course, some people are able to do the next steps without any issue, but a couple of you have been reporting some issues as far as linking back when you're trying to send this folder here to GitHub. So if you are one of those who encountered the issue, please check the Q&A section for week 1. That's where you'll likely see the challenge, the different solutions as far as how to troubleshoot what's going on for your particular computer. So, once again, the very first thing you should do is verify that yes, indeed, our GitHub account is actually linked, because you can't send it to GitHub if your GitHub account is not yet linked. And then what we're going to do is we need to install a package called the use this package. So this is our command repository. So we'll be using the install that packages function and then placing the package name that we want to install within the quotation marks. So in this case, quotation marks use this. And we're going to go ahead and run this and it will proceed to install. And once it's installed, we need to attach it to our local environment as we covered during the first week of the course. So in this, we're going to be using the command library and then use this without the quotation marks just to attach it to our local environment, making all the functions that are present usable. And at this point, now that it's usable, if we write out the actual function command within a code block, we can then hover over it, which will open up the help documentation, providing us a little bit more information about how we can actually use this. So within use this, the main functions that are useful, at least in our daily workflow, is use git, which we kind of already did at the very beginning of the project folder creation when we selected that option. But then right now we'll be using the use GitHub option, which will basically allow us to push the changes we have made locally to GitHub so that we're able to do so. So in theory, what we'll be doing is we'll set this repository as a private repository so that the code that you wrote in it, all those documentations, are only visible to you, not to the general public. So within the arguments section, so within a function, it's within the parentheses, we'll do the private is equal to the true argument as far as what's being documented. So if we see this in practice, what this looks like is going to be something like this that we can then run and execute. Now, if this is the first time using this and you have not properly set everything up, it may not quite work. One option that you could also do is, instead of doing this step here, is come to this little ... option next to get practice within your source control tab. And from there, you'd have the option of publishing, which is basically the same process that the use this package is doing, which has worked for the people who this worked through did not work for them on the first get-go. So these are the two places you can go to try to do this, pushing your local version of the project folder to your GitHub account. So what you'll end up seeing is if you run the use GitHub parentheses private equals true command, it's going to start up the process of sending your local project folder to GitHub where it can be used later on. So in this case, what you're going to be doing is you'll see the initial part of this display as showing setting active project to your project folder. It will ask you, because if you notice up here, I had some changes I had not yet staged. Do I want to incorporate them in before all this data gets sent to remote? In this case, I don't remember exactly what I selected, so let me double check. I don't remember what I did. You can either include them or you can decide not to. You provide the appropriate number right here in the selection section and hit enter at that point. At which point the use this package will then execute the actual series of git commands that are needed to get your local repository up and available on your GitHub account. At least in theory. So if this works out properly, you'll see a little display that kind of looks like this. You'll see it's creating a private GitHub repository on our GitHub account. It's setting the origin, it's pushing to main. The pushing to main step is where your actual data gets transferred over to your GitHub repository. So if this errors out, kind of similar to what other people in the course have been seeing, check to see if this step has gone successfully and if your GitHub account will actually show a repository, it just doesn't have the project name. If that's the case, there's a solution for that in the Q&A section of the discussions page, so circle back to that one as need be. And then if this is all worked out correctly, you'll see this little positron pop-up asking, do you want to see your GitHub account to see the new repository? If you go ahead and select open, you're going to basically see it pop in. And those initial couple commits that you have made locally will now be visible. All the files that we have actually staged and committed are now present on the remote on your GitHub account, where they're backup and secure in case you need them for a different purpose. So if you click on the commit option, which was this one right up here, you'll basically see what we used to be seeing within the primary left sidebar, but you'll see it in a slightly different view. Now there's also the option of, you can see these are what we know as the little hash numbers. So if you wanted to revert back to a particular point in time, you would need this number and copy and paste it in to be able to revert back to that location. There's also this little option to basically visualize the repository as it was with all the contents it was at that particular point in time, which is quite useful to like how much has my repository changed since 6 months ago in terms of total progress, those kind of questions there. So this is selecting that option, which would then let you do it. So now that we have done this initial setup, we don't need to rerun this line of code accidentally because you already have that repository created on your GitHub. If this line of code triggered again, it would basically try to overwrite what you already have. So in this case, what you need to do is there's options as far as specifying code chunks, as far as whether they actually get run or not. To do so, you basically do this little hash symbol with the little pipe sign, and then it often will form the syntax of eval colons false. So we'll visit this a little bit later in the actual quarter walkthrough. But for now, let's just go ahead and set this code block to not be evaluated by setting it to false, which will prevent this from triggering without actually being intended and then trying to overwrite the actual files. All right, so at this point, to recap, we have gone through git add, we have gone through the git commit, as well as we made sure we've able to push the changes that happened locally to a new GitHub repository. At this point, we have only been editing our example.qmd file. There's still a couple other files within our repository that are still being untracked. So at this point, I should go ahead and emphasize what these are for. So there's some things that are occurring within our project folders we don't want version control to track. Namely, if you have passwords, you don't want your passwords shared on GitHub because worst case scenario, if GitHub ever gets hacked in the future, you don't want people to have access to those passwords. Same thing, FCS files can be quite massive, and GitHub can only let, I think it's 50 megabytes per file size go up. So especially if you're working with spectral flow cytometry files, you don't want all your spectral flow cytometry files to be added. But instead of having to manually select which ones can and cannot be sent on a given particular day, if you add a particular object to a .gitignore file, it will basically ignore, pretend they're not there, and you won't have to constantly be reminding yourself, don't include your passwords, don't include your history, don't include your FCS files. So that's the purpose of a gitignore file. The gitignore file itself can be kept under version control because this is basically a file saying, don't include these particular types of files within what's sent back and forth to GitHub. And then your README file is kind of similar to what we had for when we set up your GitHub account profile. README is oftentimes what I'll do in the context of a project folder is I'll keep things that are useful as far as documentation of what's the big broad idea of what's happening within this project folder. I'll place that within the README so that when I'm looking at it, I can have a quick place to go refer back to so I know what was this project folder for originally. And the same descriptions I had just done here. And at this point, since I have described what these are actually for, let's go ahead and add them by clicking add, or if you're trying to do it via the terminal, you can do it that way. And then once they're there, you'll see they're now present as a staged commit. And go a couple clicks down. You can also, if you have lots and lots of files, be able to do it directly via the terminal by using the git add and then the little period sign. The period sign basically stands for all the contents of this folder. So if you're doing this via the console, you'd see something like this, git add period, which basically adds all files that are currently under state changes. You can also do this by hitting that little add all option that pops up if you hover. And then at that point, just write your commit message either via the actual user interface or via the terminal, whichever you prefer. Depending how many hacker movies you watched in a particular day, you may want to do more of the terminal move. If you don't want to hassle with accidentally mistyping stuff in the terminal, using the positron user interface is perfectly acceptable option at that stage. And once you have committed, you'll see that this is now visible. So now that we have actually backed up our data on GitHub, you'll see there's a little cloud option, which is basically showing where's the last commit as far as available remotely, versus the main option is showing you where's the last commit that you have in the context of available locally. So at this point, what we need to do is basically we need to first send our data up to the actual cloud itself, up to GitHub itself. So before we end up pushing our data, meaning our change that we have just instituted up to GitHub, we need to make sure that there's no additional changes that have happened to a GitHub account since we last used it. So this would often happen if you're using a different computer or if you're editing something directly on GitHub via the web. You don't want to have something that's slightly ahead and something that's slightly behind when you're trying to bring them together. So this is a situation like right before you're going to send data to GitHub, run the little pull function just to be able to keep things in a consistent manner to reduce the total merge conflicts. So if you're doing this via the terminal, you just do git pull to bring in data from your GitHub repository. If you're doing this from the little drop-down options, it's those three little periods, and then it'd be this little pull selection that you have here. And once you have verified that, yes, there's no additional changes present on remote, that the only additional change you have is all the local one, we can proceed the same way for pushing our data, which is basically sending it to GitHub. And kind of same way, you can do this via the terminal with the git pull. Or once you're ready, you can just hit that sync changes after your commit message, which will do the same process of sending this remotely to GitHub. And once that's done, you'll see that not only is your cloud and the main, which is referring to local, both in the same location, but that they now are matching each other. So at this point, everything you have locally is at the same stage that you have on your GitHub account. All right. So now, if we go back to our web browser and check up our GitHub account, we'll see that this new commit is now present, and that is now available. So the benefits of having this as commits, which are basically kind of like those waypoints, stage points, like if you're thinking of it in a video game context, is you could do all these changes on a day-to-day basis. You can get out and make things more just to see if it works. And then worst case scenario, if you completely mess things up and you need to revert back to a previous stage, you can just quickly find that git commit hashtag and then return to that particular point. Nothing lost, and everything is good to go. So if we're looking at it in this context, when we're viewing things from this window, I think for this one, I created an additional file that I'm going to be adding to its own commit. And then I'm going to basically commit this, make it part of the version control track record, but then fall back to one of our previous commits that we have already done just for this example walkthrough. So you can see I made a commit containing this revert test.r file. It's now present. We have it as the main. We can still see our remote is present back here. But if we hover over this little remote, we can kind of see this little hash symbol, which is the git hash. So if we want to fall back to this point and ignore all the changes that have happened to the version control, it's this little number that we see here that we need to grab. So fortunately, within Positron, there's a little copy icon that you can just select to be able to move forward with it, which is what we'll be doing. And then within the terminal, what we'll be doing is we'll use the git reset command and paste that specific hashtag right afterwards. Obviously, don't try copying and pasting this by eye and typing. Just do the copy paste regular. And at that point, what you're going to see is it's going to revert back. So you no longer have that additional commit history. You're now back to the point where you were prior. You still have the particular actual file that you were working with. It hasn't been lost as far as the changes go. So, with what you just covered was basically the vast majority of everything you'll ever need to do. Now, before I move on too far, if you did the git reset with a argument for hard, it would get rid of all additional files that were made after the fact. So you don't need to do that on most of the everyday ones, but if you particularly have something that's being problematic, you can do a hard reset where nothing after that point is still present within your project folder at that point. So if, for example, if you accidentally end up generating 2,000 files, you don't need to delete 2,000 files. You can just reset back to that version control. So branches are a useful feature. Basically, they create a parallel universe, a carbon copy of your existing repository, at which point you can make changes on that one perfectly free, knowing that nothing that you're going to do is going to affect your actual code that you have that's being used actively on a day-to-day basis. You can also then bring in things that are useful and things that are validated and things that you know to your actual main branch, which is what you'll be able to do. So in the context of the course, we often are using those branches, and especially when you're turning in the optional take-home assignments, we have a homework branch, which is what you're submitting to at that point in time. So I'm not going to go too far in depth for this one, just because at this point, you've covered the main concepts of version control and Git that you need for the very beginning of the course, but I just want to touch on it so you're aware of the concept, just so that if you do need to go in and start doing parallel branches in the future, you at least have some context and you can refer back to this video when the time comes. So if you're doing this via the terminal, you do git branch, and you can see currently within our project repository, we just have a main branch. There's no branching forks of other parallel universes being present. So if we wanted to create a new branch, for argument's sake, let's go ahead and say we're doing the week 1 branch at this point. you could specify git branch as our command, and then add week1, which is going to be the branch name, and then hit enter. And now, if we run the git branch command again, you can see we have 2 actual branches present within our GitHub, within our version control being tracked. The little asterisk mark denotes the branch that we are currently on, i.e. being on main. Now, besides the terminal, as with everything with Positron, we can also create a brand new branch via the Positron user interface. So depending which one you prefer doing, you can do it on a given day basis. Basically, it's those little 3 dots in a row, down to branch, and then down to the create branch option. And either one of these is going to get you to the same point. Now, if you want to switch between your current branch, currently we are on main, but let's say you were trying to go into that parallel branch to do some changes, to make some edits, so you can rely on those later on in the future. At that point, what you can do is you're going to do git checkout, which is the command in the terminal, and then you're basically going to specify the name of the branch you're trying to switch to, so in this case, week1, and then you're going to hit enter. And then, once again, if we go ahead and check where we're at, we'll see that we've been switched around and we're now present within the week1 branch. So you'll see at this point, when you start messing around with branches, each branch has its own little color symbol, which will then be used depending on if you need it or not. So having switched to the week1 branch, let's go ahead and create a additional Corel Markdown file that we can then make edits to that we know is not going to be present on the main branch for our regular day-to-day usage. So as we're seeing this, we're going to go ahead and create a new file. Once it's up here under the new file little icon that will pop up in Positron. And let's go ahead and just give it some basic skeleton of a detail as far as YAML and some text. Once that's done, same process as far as adding it to version control for that particular branch. We're going to stage it and then make it available via commit message. My branch commit is basically going to be that commit. And once this is staged, you can now see that you now have week1 being located here versus our main branch is still 1 commit behind. So this is kind of like it's a garden of forking data where each branch is its own little universe. It's self-contained. It can have its own commit history that can then be made available to the rest of the file as we need it. So if we then went back and checked on GitHub, what we can see is currently we're set our main branch, but once we have made commits to the parallel branch, you can also see it pop up. If you wanted to see what's in your parallel branch, you do this little option of dropdown, and that will show you what current branches you have active. So let's go ahead and switch it over to week branch. And as you can see, we now have that branch test.qmd also available via GitHub, which is serving as our remote location. If you wanted to compare what's the difference currently between the main branch and the weak branch, we can do the little option, which is this one up here, which would be the compare and pull if you were trying to compare it to the main. And what you're going to end up seeing is a view that looks kind of like this, basically saying comparing week1 to the main branch. There's this additional file, there's this additional commit, this is what is present. There's nothing that's causing a conflict, so if you wanted to, you could merge these together, bring them all together, unite the streams basically at that point to be able to use them down for whatever next purpose you want to do. So this is the initial coverage of branches. We'll revisit this later. There's a lot that you can do as far as creating and pruning the parallel branches to make sure your workflow is consistent. This is more on the advanced side. For now, the initial concepts we covered at the beginning of the Git walkthrough is what you need to do for the rest of the course. So our walkthrough, we've created a new project folder locally, we've added files, and then we've pushed all that changes that we made to GitHub. The way we did this is we first needed to do some of the version control steps, namely we needed to use git add, we needed to use git commit, git pull, git push. If you're feeling a bit overwhelmed, please know that this is perfectly normal. We have all been in your shoes. Git is not the easiest topic to understand, but it is a very incredibly valuable skill set to know over a longer period of time. So in this next section, the next walkthrough that we'll be going through, we're basically going to be talking more about the Corel Markdown files, the different types of arguments that we can make as far as being able to modify them, customize them, get the different types of outputs. So once again, thank you for your patience. We are now through the actual walkthrough. I'm hoping compared to the last attempt about an hour or so ago, where I was stuck on the very first slide for the first 8 minutes of talking, this has continued throughout the progression, and it's actually a good audio recording. So with that, thank you for your attention, and I will see you during one of the live streams.